Hello, welcome to the stream for the Ariane 5 launch, which is the last launch of the Ariane 5 for um, the whole Ariane space group. They're actually going to be switching now to the Ariane 6, so it's a bit of a sad day in that respect, but in the same respect, we can also pay tribute to this wonderful vehicle that's been flying for almost 20 years now, I think. So I hope that we can enjoy it together and learn a little bit about this vehicle. If you haven't already, this is your last chance. I also have some exciting news to share about ASTRA, so we'll also be doing that a little bit too. If you have been following this channel for a while, you'll know that, well, we haven't really been posting a lot in the last month. In fact, I don't think I posted a single video for this whole month. But there's a good reason for this, because we have been actually propulsion testing. So for the last 2 weeks, we were at DLR Lampleshausen, which is a test site, which is just a little bit north of Stuttgart, which is one of the places that you can test rockets in Germany. It's kind of more of a professional test site, because that's actually where Ariane Space actually tests their rockets. Like half the facility is just for them, basically. But there is some smaller test locations there that you can get access to if you're a student group. And that's what we had the opportunity to do. There's a little stand there called M11.5. Some other student groups also test there, specifically high end. So if you're familiar with that rocketry group in Germany, they also test at that test site. So yeah, we were testing there and had some interesting results. Unfortunately, the video for that test is not quite ready yet. We do need to get approval in order to share it officially worldwide. And we're also still compiling what we just tested and trying to make sense of the data, so to say. But stay tuned, because in a week or two, we will be sharing some of the video from that and also some of the results and what the heck was going on. But what I can share with you today is actually some of the interesting things about what we built before and how they fared in the testing, because I have some parts here that kind of describe a little bit of the story. So we will be getting into that in some of the inter periods between the rocket launching and things that are going on. So we're definitely gonna have to go over some of those things. I think that'll definitely be interesting. Yeah, why is approval needed? Approval just to show the footage. Basically, like whenever you're testing at like an official place, this one's officially at the DLR, which is like the German NASA. So whenever you're showing footage, even if it's your own stuff, like our own test bench and stuff, we're still technically on their facility. So we have to go through a whole like approval steps in order to actually show video and stuff. That's just kind of the way it is, you know. we're just, you know, there as guests at their site, so yeah, we can't just be sharing whatever we want. This is also the reason why we couldn't live stream there. In a perfect world, I would have loved to do that, because then you would have seen everything and seen it a bit more live and a bit more, it would be, you know, a bit more real. But yeah, unfortunately, like you can't really do that at these types of facilities. But yeah, maybe in the future we can convince them that, you know, it's okay to show stuff live. Well, we'll see. But yeah, a little bit back to what's actually happening today. So Ariane 5 is launching. The target launch time for that is in 58 minutes. That's the start of the launch window. I don't know exactly how long this launch window is, but I think they have like an hour or two to fit that launch into. So basically, yeah, this is the last launch. So hopefully it will launch in somewhere in that window today. They're going to be carrying 2 satellites primarily. So there's one that's called Syracuse-4B. That is a military satellite for the French, like the French defense and space military. Basically, it's going to be a communication satellite that will do some communication stuff for the French military. A little bit not so open about what exactly its capabilities are, but of course that's because it's a military thing. There's also another satellite, which is actually somewhat interesting because it's built by a company called OHB, which is actually centered in Bremen. This satellite is called, what's it called again? It's like Henrik Hertz. And it actually is also a communication satellite, but it is built by OHB, which is of course centered in Bremen. So there are actually some people that work at the OHB here that of course have had a little bit of an understanding of what this satellite is. So that's also super cool. But yeah, it's also just another communication satellite. They're testing a bunch of stuff with it. So it's kind of like a test bed for different types of communication technologies. Yeah, communications isn't my strong suit when it comes to the space stuff. So what exactly it does, I don't really know. But it is another example of space stuff that's going on inside of Bremen, Germany. So definitely cool to showcase. And awesome that OHB gets featured on the last Ariane 5 launch. So that's always cool. Anyways, if you're not familiar with the Ariane 5 vehicle, then let me give you a quick rundown. Of course, it's basically it's a heavy lift vehicle, so it's designed specifically to get payloads all the way to geostationary orbit. And it does this in 2.5 stages. So it has the core stage, and then it has those two boosters on the side. And those two boosters are powered by solid rocket fuel. And the center stage is basically just a liquid oxygen and liquid hydrogen engine. Those boosters give the whole thing enough thrust to get off the ground because the core stage is actually not strong enough to lift it off the ground all by itself. So those outside stages will, the boosters will kind of burn for a minute and a half or so, and then they'll separate, and then the core stage will take it most of the way to orbit. Then there'll be another separation event, and you'll see that upper stage take off and send the payload all the way to geostationary transfer orbit. And yeah, its payload capacities are there. It can do about just under 7 tons to geostationary transfer orbit. And that's kind of the bread and butter. And it's able to do 2 satellites at once, which again, it will be doing on this mission. And that's kind of one of the main selling points of the Ariane 5 and what makes it actually quite a good vehicle for doing this particular type of mission. And potentially probably the best vehicle in the world at doing it. So it's, again, a bit sad to see it go. It was definitely a hallmark of its era. Oh man, am I losing my computer? This is not good. Okay, stand by. I'm having some computer difficulties. I'm not sure exactly what's going on, but it looks like my computer is trying to restart or something. I am not sure. Huh. Interesting. Okay, never mind. Everything's all good, it looks like. Okay, apologies for the slight difficulties I had there. We will continue. So, yeah, that's basically the rundown of the Ariane 5 vehicle. So nothing, probably nothing too new to you if you're familiar with, Arianespace and their launch vehicle. Also, if you're familiar with their engine, they basically are running a gas generator engine. This is, of course, something that was quite common in the era that the Ariane 5 was designed. So essentially, it's a rather simple design. You just have fuel and the oxidizer go into a pre-burner, and that's the location which basically there's an initial reaction which can power the turbines that actually drive the pumps. And any fuel that's burned in the pre-burner just goes overboard through the exhaust channel. And the rest of the fuel and oxidizer go into the combustion chamber. So yeah, this is the Vulcan engine design. This is, of course, getting updated for the Ariane 6. It will be a similar design, I think, but just small improvements. So yeah, looking forward to seeing that fly again today. But coming back to what happened with ASTRA at the propulsion testing. So one of the first things that was maybe interesting about our test stand was the bronze nozzle. So we made a video about this. Basically, we designed a nozzle out of bronze and graphite and Pertnex. And the reason why we did this was because we wanted to basically find a way to build a nozzle for really cheap. You like my sweater? If you want to get the sweater, by the way, you can check for it in our merch shop. I think I might have a link to it in the description. I'm not sure. If I don't, I'll have to put it there eventually. But if you look for our merch store, you can get the sweater here. And we have a bunch of other stuff with different designs and stuff. If you're curious about why we have this design, it's because we have a mascot. It's basically this little octopus here. Her name's Octavia. She's going to be the first octonaut to reach space. That's the plan anyway. She's everywhere for our testing. She's always very brave and on most of our test devices and things. She was also there for the propulsion testing campaign, and she has quite a story. So yeah, she's also now on the sweaters too. But yeah, so the question is how did the bronze nozzle fare? So like I said, the reason why we chose the bronze nozzle was because we wanted to find a way to make it for lower cost. And if you watch our video, you notice that we were able to cast it, because we can cast the bronze just using aluminum and copper. So we melt them together and then we can cast the shape. So that's pretty cheap for us. And then it's just a matter of machining some insulation onto that and some graphite at the throat to make sure that it's all thermally okay. Now, it looked a little sketchy, maybe, for those who are more experienced rocketeers. But I can confirm that the bronze nozzle does work. And I have the proof. Here is the bronze nozzle. This got through 5 hot fires, which is a total of about 20 seconds of testing. And as you can see, it's still totally intact. Nothing too crazy happened to it. We saw basically no erosion on it at all. It didn't have any cracks or anything. It seemed to be totally thermally performing. So we're quite happy to say that the bronze nozzle solution actually does work, at least in the bounds of what Karma is trying to handle, which are relatively short burns. Our maximum burn duration is somewhere between 8 and 10 seconds. So at this point, we're pretty confident that the bronze nozzle will work. We also noticed we have a little graphite insert there at the throat. And yeah, we checked it to see how much it was eroding. And basically, it didn't erode much at all. So we thought we were going to have to change these graphite inserts every couple of burns. But it turns out that we probably don't need to change them at all. So in the end, the bronze nozzle ends up being quite reliable, quite durable, and actually able to handle quite a lot. So less sketchy than you actually might think. It turns out you can probably make a nozzle for, under $100 if you're just a little bit creative. Because the bronze nozzle works so well, we never actually tried the expensive graphite nozzle. So that's still sitting around in a pristine condition. I think that at this point, we're probably just going to stick with the bronze nozzle because it just makes more sense from a cost effectiveness standpoint. And our design has pretty much evolved around that for now. So that's probably what we're going to stick with. The next sketchy part of our design maybe was those aluminum rings that we used in order to basically build ourselves around the fact that we're actually building a rocket that's smaller than what the original vehicle was intended to be, because of course our initial design was for Transcendence, which is the rocket that goes to the Kármán line, and this is for a scaled down version. So let me explain this a little bit. So basically, you can see here the diagram of our combustion chamber. Basically those things that are between the grain in the middle and the wall of the combustion chamber on the left, they're kind of like pink in color in this diagram. They are actually what we call spacer rings that are moving the force from the combustion chamber, which is basically the grain, and the wall to the wall of the outer casing. And those rings kind of look like this. And this is a ring that has, again, survived the testing that we just went through. It's looking a little bit black, and I can confirm that this is not the case if everything's going well. After the tests that were all going well, which was the first 4, the ring was perfectly fine. No coloring on it or anything. It looked exactly the way it looked before. But this was after we actually had an explosion on the 5th test. And even after the explosion, you can see that this ring is still basically fine. It's just a little bit black because of the soot that got deposited onto it. So another part of our design that's actually quite reliable is basically these aluminum rings. Even though it seemed a bit sketchy, it actually turns out to be actually quite reliable. And it was actually quite good at like bracing the PVC, which was essentially the casing of the combustion chamber on the grain. It was totally doing its job of bracing that and transmitting the forces to the CFRP outer casing. So worked better than we thought. Okay, you said you can make a nozzle for under $5. Well, that's quite impressive. You must be using some cheaper stuff than we were using. Yeah, I would say that we probably went through, like, we actually have to use casting sand to make a nozzle because we burn the sand when we use it. So that's some money that's involved in that too. So I don't think we make it $5. Like, we definitely go through 3 to 5 euros of sand just to cast one nozzle. But yeah. Yeah, Taha, the section view. You can just get that section view yourself. You have access to the Astrofusion, don't you? It's in the subscale folder, in case you're curious. But yeah, I can send it to you if you want. Okay, the last part of the design that is perhaps interesting to look at was actually, I mentioned that we had a failure on the 5th test because it kind of exploded. The question is, why did it explode? Well, it turns out that we have on the upper insulation, if you look there on again to the diagram, the part that is kind of brown on the top just below the injector, that is the insulation that is being put onto the injector and then is being used as the place that we push the PVC tube into. So it's kind of like a connector piece, but also it's insulating the inside of the combustion chamber from, of course, the carbon fiber casing. And this is what it looks like after it dies. So basically, these pieces were forming the wall of that insulation piece. And we noticed that after we took apart the combustion chamber that exploded, it basically, all these pieces broke apart. And we have like, 5 different pieces of these things, which indicates that they all kind of exploded and fractured at the same time. The reason for this, we think, is because Pertinax is not exactly a continuous material, so there are like weak spots on it. And we did our structural analysis based on it being a continuous material, which in hindsight was kind of a mistake. In the future, we will probably not do that. So in order to fix this, we're planning to wrap it in like carbon fiber or fiberglass or something, which should brace it so that essentially it's not acting as a structural piece anymore. Yeah. The reason why it's black is because it was basically in combustion chamber fire in the wrong places for an extended period of time, because after the explosion, the hot gas basically went everywhere. But other than that, it seemed to fare quite well. So we just have to, make it strong enough so that it can withstand the combustion chamber pressures. The pressure that we reached was 30 bar. And according to our simulations, it was supposed to be able to handle around 60 to 70 bar, at least, as a bare minimum. But obviously that didn't pan out for reality. So yeah, we definitely have to not use this as a structural item in the future. What's interesting about that, though, is that, we weren't really coming into the test expecting that that would be a failure that we'd have. So it's kind of interesting how like you can have some expectations about what might go wrong or what might be a sketchier part of your design, but in the end, it's the thing that you didn't really think about that ends up failing. Because all the sketchy parts like the nozzle and the rings work totally fine. So yeah, I guess it's just the way it kind of goes. But in the end, all this will be feeding into our next testing campaign, which we're going to be doing hopefully in a couple months. And hopefully this one will go even more successfully and we'll get our first full duration burn. But yeah, I'm looking forward to sharing the footage with you guys once we get approval to share it and everything. Yeah, that pretty much wraps up most of what I had to say about the test so far. If you guys have any questions along the way, please feel free to ask. I can, of course, share all the information about the test. I just can't share the video yet. So if you have any other questions about other parts of the design, how they worked and stuff, yeah, go ahead. Another part that was actually working quite well was the impinging injector. So if you watch the injector video, yeah, the impinging injector worked really good. And once you see the video, you'll understand what I'm talking about. It was really cool. Yeah. All right, maybe it's time for us to focus up a little bit and get back onto the train of what the heck's going on with this Ariane 5 launch. So if you're just joining the live stream now, of course, we have an Ariane 5 launch coming up. It's the last one that this vehicle is going to go through. So Arianespace will be retiring the vehicle after this. The reason why they're doing that is because they have a new vehicle coming, which is the Ariane 6. And this is going to be a upgraded version of the Ariane 5, I guess. It's going to be a little bit cheaper, so it's going to be able to compete with some of the other vehicles on the launch market, like the Falcon 9. The Ariane 5 is kind of not really able to compete because of the cheaper prices that are being offered by other launch vehicles. So yeah, time for Ariane 6 to come. The planned launch time for Ariane 5 is going to be in about 40 minutes. It's going to be launching 2 satellites, one of which is for the French military, and the other is actually for the German aerospace, like NASA. It's called DLR, and it's a satellite that's being built by OHB, which is a German company that builds satellites. And it's going to be a communication satellite, which is testing a bunch of communications stuff. So what's interesting, though, is that OHB is, of course, in Bremen. So there are people in Bremen that were involved in building this satellite. So it's really cool that it's the last satellite that gets to fly on this Ariane 5. Yeah, there's lots of history with the Ariane 5. It was I think it was one of the first like commercial rockets that was actually like commercially viable and launching in a commercial way where they're doing like hundreds of launches. So in that sense, it's actually kind of a market leader. It's that rocket and the Atlas V. Those were like the only commercial launchers for quite a while, like in the early 2000s, 1990s, 2000s. Those were the vehicles that were going. So yeah, it's good to see that there are other rockets now that are competing and able to actually make these rocket designs obsolete. The Atlas V is also retiring this year, I believe, if it didn't retire already. I'm not actually sure. So yeah, we'll see. I'm curious what you guys think about the Ariane 5. Are you happy about the vehicle and stuff, or do you think that the Ariane 6 is needed? Do you need to does it need to update itself? What do you think about the Ariane 6 in general? Is it a smart design? Essentially, it's just the same thing as the Ariane 5, just with some ways to make it cheaper, essentially. The frustrating part of the Ariane 6 is it's still not reusable, which is kind of, I think, the innovation that's required in order to actually get change. But yeah. Okay, it looks like the stream for the Ariane 5 is up now. Let's just quickly switch over to that. They got some cool music going on here. Oh, I'm in the way of the clock. Okay, so the clock is a little deceptive. I don't think it's actually launching in 6 minutes. I think it's just the show that's going to start in 6 minutes. So don't get deceived. Yeah, I agree. The Ariane 5 was definitely one of the, like, it's definitely one of the most, I don't know. It's like the launcher of the era, you know? Lots of important satellites were launched on it. I mean, just recently, James Webb was launched on it. A lot of satellites that went out to deep space were launched on it. I think the Cassini was launched on it. So, like, lots of legacy there. My personal favorite space mission, at least of the last 20 years, was definitely Cassini. So, definitely cool. Cool to see it. Cassini wasn't. I thought Cassini was launched on Ariane 5. Was it launched on an Atlas? Or was it launched on the Delta IV Heavy? I don't remember. It was before I was only like 3 or 4 when it was launched, so I don't remember it. It was a Titan 4B Centaur. Oh yeah, because this was before even any of these rockets were online. Of course. Yeah, all right. Yeah, is the Ariane 6 competitive? Well, that's a good question. I have a slide that kind of looks at that question. So here's the difference between the Ariane 5 and the Ariane 6. So, like, the primary things that you see immediately are basically like the cost. So the cost is about half of what an Ariane 5 is. Like Ariane 5 was 150 million a launch. Ariane 6 is looking for around 75 million, which is essentially making it competitive with a Falcon 9, because Falcon 9 comes in at about 67 million. But the big difference is how much payload goes to geostationary transfer orbit, because Ariane 6 can only do 4.5 tons. But the Ariane 5 was able to do, like, you know, somewhere on the order of 10 tons. So this is kind of like a key difference, I would say. And they're basically coming from the perspective that, well, a lot of satellites are a lot smaller these days, so we don't really need that giant payload capacity to geostationary transfer orbit. So yeah, that's kind of the way Ariane 6 is being built. Yeah. However, I would still say that from a specs perspective, Ariane 6 is still not competitive with the Falcon 9, because if you look at the Falcon 9, like, it's able to get over 5 tons of payload to geostationary transfer orbit in reusable configuration, which means that they can literally charge the 67 million and maybe even give discounts in order to get the same mission that an Ariane 6 can. So the only real difference between how these two vehicles perform is basically the size of the payload fairing. So you can see that Ariane 6 has like the big 7-meter payload fairing. So if you have a very voluminous satellite, obviously you'd be going on the Ariane 6, because the Falcon 9 can't really adapt to that. It only has the I think it's a 5-meter payload fairing, so it's, you know, a bit narrower, and that can be a little bit tricky. Is someone asking whether I will go into the rocket? Yeah, no, I will not be going on the rockets just yet. I would love to, but yeah, the rocket's going to be launching in, I think, about 35 minutes or so. Yeah, the official time that is listed is in 35 minutes. So it's coming up in a little bit. Hold on to your horses. And also just keep in mind that it might get pushed a little bit as we go, because they do have a bit of a launch window. So yeah, that's just the way rocket launches go. So yeah, in terms of competitiveness, I would say Ariane 6 is definitely better than the Ariane 5 in terms of cost, because it could be a lot cheaper. But in terms of overall competitiveness against the Falcon 9, I don't know. It's going to be tight. Basically, they'll be catering to payloads that are specifically very large and voluminous, but not so heavy, which tends to be a lot of the payloads these days. But, you know, yeah, I think they will struggle to find the same amount of customers as, like, for instance, SpaceX gets off the Falcon 9. Yeah. Yeah, hopefully, I don't think there's going to be any boats. Come on, guys. Remember, this is launching from Kourou, which is way down in French Guyana. So I don't think there's as many boats as there are around the Florida region and stuff. So should be a little bit better in that respect. All right, it looks like the live stream should be starting up anytime soon here. Ah, here we go. Maybe they'll do a little bit of a homage to the missions that have flown already. So that's the Vulcan engine there. Yeah. All right. I don't know if they're going to start with the live stream yet, but now they're just showing Kourou. This is Kourou, where they launched the rocket. It's, of course, a very tropical location.
Welcome to the Guyana Space Center and the launch of Heinrich Hertz satellite and Syracuse-4B on the last ever Ariane 5 rocket.
Our passengers are here on the pad, inside the top of the rocket, ready to begin their ride into space. The teams in launch control, about 1 kilometer from the pad, are performing the last crucial operations before launch.
Over the next hour, we'll be bringing you live coverage from here, the Jupiter Mission Control Center.
And we will take you on a VIP tour of the new Ariane 6 launch pad. I'm Raphael Chevrier.
I'm Katie Haswell, and welcome to Flight VA261.
And the start of our satellite's journey on the road to space.
All right, sounds like fun here. Maybe we should talk a little bit about the launch phases of the vehicle.
Running smoothly here at launch pad number 3, where today we are turning a page in space history. The last of the Ariane 5 rockets is waiting to make her final journey into space. before passing the baton to Ariane 6. And our passengers up there sitting comfortably inside the cargo bay, inside the fairing, waiting to start their ride. That's due in about 27 minutes' time. You can see the countdown there on the top right-hand side of your screen. I'm in the Mission Control Center. Behind me in what we call the fishbowl, the operational teams, all focusing very hard at this point before the launch. This is very much the nerve center of operations here at the spaceport. Right now, all systems are green. That's a good sign. It means that we are go for launch. So we can find out a little bit more now about our mission. And just the man to tell us all about it is Stéphane Israel, who is the CEO of Ariane Space. Thank you very much indeed, Stéphane, for coming out of the fishbowl to talk to us. So first of all, we were going to be meeting here on the 16th of June, but that launch was postponed. What's been happening since then?
Yes, first we have had to replace 3 pyrotechnical transmission lines. It has been done properly. Then 2 days ago we have had a red with the weather, so we have decided to postpone the launch to tonight.
And we're good to go?
We are very good to go.
So those pyrotechnic lines he's talking about were what delayed the launch from 2 months ago. Probably had something to do with the separation systems of their pyrotechnic lines. But interesting.
So that's a really nice, comfortable launch window, isn't it? And of course, we've got our 2 satellites on board. Do tell us a little bit more about today's mission.
2 very important passengers for this last Ariane 5. First, a German passenger, Heinrich Hertz satellite, which has been manufactured by OHB System for the German space agency DLR. And the second passenger, Syracuse-4B, for the French MOD, which has been manufactured by Airbus Defence and Space with Thales Alenia Space.
And of course, today it's the last Ariane 5. The teams have been working on this fantastic rocket for many, many years now. I can't imagine how people are feeling.
People tonight and all the team are moved because it is, as you have said, the last Ariane 5, and focused because what we need now is to make the final preparations for the final Ariane 5 launch. So moved and focused.
Yeah, absolutely. So Stéphane, thank you so much for that. So you can head back now to take up your position in the fishbowl, and good luck for the operations. Thank you, Stéphane. So, after 27 years, the mighty Ariane 5 is hanging up her boots and retiring to hand over to her younger sister, Ariane 6. Very exciting times ahead. Many of us, though, have grown up with Ariane 5. I certainly have. My first ever launch broadcast was the first operational Ariane 5, when she delivered a fantastic telescope into space called XMM Newton, which is still delivering really important technology, information and data back to us now. And that launch was in 1999. Someone else who's grown up with her is our technical expert today, Raphaël Chevrier. Raphaël, thank you very much for being with us. It's really lovely to have you here. Raphael's going to be with us now for the rest of the show. Raphael, what does she mean to you?
Well, you know, I was 10 when the first Ariane 5 lifted off, so for me she really is an icon. She became part of our collective culture. As a child, it really felt that she was the way of reaching the stars, you know.
Yeah, and she has delivered some really incredible
I was only 6 when it
spacecraft
launched.
over the years. Spacecraft which I think we can
He's only 4 years older than me.
Lives.
Oh yeah, and I really want to pay tribute to all the remarkable brains and the incredible people who actually made those missions possible and who are still inspiring me on a very personal level. Thanks to them, we've been able to send any type of satellites into any kind of orbit. Satellites to help us understand the planet, the climate change. Satellites to help us better communicate with each other, to understand our universe, where we are, where we come from, to help the armed force, and also cargo ships to supply the astronauts on the International Space Station. So this is no exaggeration saying that Ariane 5 actually changed our lives.
Yes, indeed. And today she is carrying 2 very, very important passengers into space. How are they going to get there?
With Ariane 5 standing right now on the launch pad, so today we are launching towards the east, as it's usually the case for reaching the geostationary orbit. So 2 minutes and 21 seconds after liftoff, the 2 lateral boosters have provided 90% of the thrust, so they will be jettisoned. Shortly after that, we will separate the fairing as we have crossed the limits of the atmosphere. So at that time, the satellites can safely face the emptiness of space. Once we have reached an intermediate orbit, the main stage will be cut off and separated. This will be 8 minutes and 40 seconds after liftoff. Then the upper stage will...
Hey there, Emmett. Great to see you.
16 minutes in order to reach the intermediate orbit where the satellites will be released. By the way, the little towers that we see here on the motion picture, they represent a chain of telemetry stations receiving data from the Ariane 5 all along the flight path. So H2SAT will be separated first after some orientation maneuvers before we safely separate the dual launch structure. It's called the SILDA, that's the black box that we see here, under which the lower passenger, Syracuse-4B, is hidden. Syracuse-4B will be separated 33 minutes after flight. And then exactly like a relay race, we will pass the baton to the customers who will acquire their satellites and perform all the orientation maneuvers in order to get them into their final geostationary orbit, 36,000 kilometers from here.
That's a long way up. And as you say, Heinrich Hertz is in the upper berth, up there at the top, the first satellite to be released. OHB led the industrial teams who built it for the German Space Agency.
So it's actually pretty cool how they nest the payloads in, which allows them to carry 2 big payloads up to geostationary transfer orbit. They basically have like the first payload sit on top, and the second one is like covered by a shell, and then essentially the first one gets like pushed off, and then that shell can come off and reveal the second one underneath. So it's kind of an interesting way to deal with multiple big payloads on a rocket.
Is Germany's new Heinrich Hertz satellite, communication satellite.
So this is the communication satellite that OHB is building, which is of course of interest to people who are in Bremen because OHB is in Bremen.
Communications can result in high data rates for mobile end users.
Our Heinrich Hertz satellite is a communication satellite. It has a total mass of about 3,450 kilograms and is roughly the size of a small van. This is now the first communication satellite in Germany for about 30 years, and our goal is to demonstrate the newly developed technologies for communication satellites in orbit. We want to provide proof that these technologies are qualified for orbit using our scientific technical payload and the military payload to provide communication links for the National Army.
Yeah, it'll be interesting to see how it performs because, like they said, it's it's been a while since Germany has launched a communication satellite, so I'm sure they have some new systems on there to test out and see how they're working.
And the propulsion system is supplied by Ariane Group. With the Heinrich Hertz mission, OHB system the prime partner, along with 41 other partners from the German space.
They're kind of launching their own satellite. Ariane Space is, of course, a French company, so technically the French are launching it for Germany. Of course, Ariane Space is kind of a Europe-wide organization, so Germany is part of it a little bit. But I would still say it's more the French launching the German satellite than anything else.
Syracuse-4B. It's a military satellite for the French armed forces, and it was built by Europe's aerospace giants, Thales Alenia Space and Airbus. It's very powerful, it's very resilient, and it can resist even the most extreme jamming, and that's exactly what the military need for their operations. Let's take a closer look at Syracuse-4B.
Yeah, Syracuse-4B is much more of a military use satellite than a commercial one.
Ariane 5 is launching Syracuse-4B, a French military telecommunications satellite that is part of the Syracuse-4 program. At the forefront of technology, the Syracuse-4 constellation is being developed by the Directorate General of Armaments in collaboration with the National Center for Space Studies and the Armed Forces, and built by Airbus and Thales Alenia Space.
La nouvelle génération fondée sur les satellites Syracuse-4A et Syracuse-4B offre une augmentation des débits de communication et une protection accrue de nos terminaux.
Yeah, I don't think you're going to find the Syracuse 4B source code anywhere. Unless you're French military. But yeah. What I have to say though is that I feel like Europe is a little bit more open about their military satellites than the US. So like if you're a military satellite payload on a US rocket, like they wouldn't even have a live stream after the separation of the core stage. But in this case, I think they will give a little bit of live stream. Although I'm not sure if they're just going to show the data of it going into orbit and not actually, like usually Arianespace doesn't show the camera on the upper stage. So, which is a little bit unfortunate. Maybe on Ariane 6 they'll have cameras on the upper stage. That would be really awesome. Hacking the satellite. Yeah, I don't know, man. They usually try to make these so that the novice hacker is not going to be able to get in. Yeah, the radiation hardened stuff is actually quite expensive. Like if you think about just the electronics you'd use to try to build a satellite and stuff, usually it would be, you know, on the order of maybe a couple hundred, maybe a couple thousand euros if you just was random electronics. Like that's pretty much what it is for ASTRA, for Karma, or for Transcendence, sorry, the one that goes all the way to the Kármán line. Like we were just going to use normal electronics. But what makes it difficult for space is that you actually have, if you're sending a rocket into orbit, then you're going to be in space for a while and you need to radiation harden because, of course, you're going to get way more radiation from the sun, and that can cause problems with, you know, upsets because of basically radiation coming and knocking around and having issues with transistors and stuff. So yeah, you have to harden everything. You have to have lots of redundancy, and all of that makes the cost of all your electronics go up a lot. And sometimes it can be like hundreds of thousands of euros, depending on how complicated your flight computer has to be. Yeah, hopefully nothing from AliExpress. Yeah, I probably not. Yeah, it's a little more sophisticated, I guess.
The transfer of the whole thing to its pad, that took place 2 days ago, and we actually filmed it, didn't we? We did a live show because it's a very special event, the last ever transfer.
It's a very special operation that is very specific to Ariane 5, so it's a very slowly process. The whole launcher and the table, it weighs 2,000 tons. It's towed by a small truck, and it's traveling 3 kilometers or so.
I wonder if they will do the same thing for Ariane 6. Like, maybe they could update that a little bit and make it a little bit quicker. Because obviously that's a huge bottleneck to launching, is they have to drag the entire launch pad out every time.
And on launch pad number 3, we have a number of different launch pads here, though, because the Guiana Space Center is a big place. We have lots of different facilities. It covers about 700 square kilometers. I think it's about 3 times bigger than the capital city, Cayenne. And the whole thing is known as the range. The job of administering it and managing it falls to the French Space Agency. Over to their president.
Good evening. Today will go down as a day to remember in France and Europe's space program. In a few minutes, Ariane 5 will be lifting off for the last time from CSG, the European Space Center. I would like to dwell on this special and heart-stirring moment to recall some of the fantastic feats of this venerable launcher, the flagship of Europe's space industry. Between 1996 and today's final flight, Ariane 5 has clocked up 170 launches. With its unique lift capacity and orbital injection precision, it has carried a host of payloads into space, serving telecommunications, Earth observation, and space exploration missions. Let me reflect on some of these emblematic missions. Let me start with Rosetta, which embarked a one-way trip to Comet Chury atop Ariane 5 on March 2004, going into orbit around its target. 10 years later, an odyssey followed all over the world. Galileo, the best worldwide known European positioning service. More recently, the Webb telescope, launched on December 21, that is sending back stunning pictures of our universe. Today, we are poised to launch Syracuse-4B towards a destination which is much closer.
I think James Webb will probably be the most iconic mission that gets launched on the Ariane 5 in overall.
Developing this satellite, both on technology development and project coordination, has been instrumental as a space architect of Syracuse-4 program, providing its expertise to the Defense Procurement Agency, DGA, and to the Armed Force. This evening, Ariane 5 is therefore bowing out with a mission crucial to sustaining our military capabilities. I wish you a great launch, another fine chapter to add to the history of Europe and France space program. We can be proud of what we have done, and we can be proud of this illustrious lady. Go Ariane 5, go!
Another interesting tidbit is that the Ariane 5, which was launching the James Webb Space Telescope, was actually the first launch that ASTRA streamed. So it even goes back to what we did first as well. I'm sure you won't have to wait 1,000 years for Pakistan to have a space program. Come on. I mean, they already have lots of technology development there with like missiles and stuff. So how far is that away from building a rocket? Just need enough people who want to do it.
Exactly. But what we typically check is the wind at high altitude, the wind around the launch pad, and the risk of lightning that could damage the electronics during the launch. Rain is not so much of a problem, and that's a good thing because it's been raining quite a lot in the past days. We are in the tropical weather here in French Guiana, and we are actually in between the rainy and the dry season.
Yes, it's not called the Amazon rainforest for nothing, but it's actually a very good place for launching rockets from, isn't it?
Oh yes, it's an ideal location for launching satellites into space. In French Guiana, there is no big tropical storm, no hurricane, no earthquake, and more importantly, we are located 5 degrees north of the equator, which gives us a maximum slingshot effect given by the rotation of the Earth. French Guiana has also an...
What annoys me is that people always mention that French Guiana is the best location because of the slingshot effect, but this is actually not really true. It is good for the slingshot effect because you do get another like 400 meters per second that you get just because you're going with the rotation of the Earth. But there's actually an even better reason why you want to launch in French Guiana, which is that you pay less of a penalty for changing the inclination of your orbit. So if you launch a satellite, let's say at Cape Canaveral, which is at 28 degrees inclination, it means that the shallowest inclination that you can have when you go into orbit is 28 degrees. If you want to get into geostationary orbit, you have to get that orbit to 0 degrees. And you have to pay a huge delta V penalty to make the orbital correction to get from 28 degrees to 0 degrees when you're on the geostationary transfer orbit and going out all the way at the top and circularizing. It's, in the end, if you do the math, it's about like 1,500 meters per second of delta V. But of course, if you're launching from French Guiana, you already are at 5 degrees. So that delta V penalty that you pay to change the inclination of the orbit to 0 degrees is much, much, much smaller. It's like only, a couple hundred meters per second of delta V. So in the end, launching from French Guiana saves you over 1,000 meters per second of delta V because of the inclination, but only about 400 meters per second of delta V because of the slingshot effect. So I just find it funny that everyone always mentions the slingshot effect because I feel like that's like what makes most sense to you immediately about why French Guiana is positive as a location. But the actual reason why it's most interesting as a location is more to do with the inclination. So just as a little, a little fact to keep in mind. And also if you're looking for a launch site and you want to launch geostationary, like geostationary orbit type of satellites, pick a location that is close to the equator specifically because of that.
If for any reason the clock happened to stop, we have some time in order to understand what's happening, to solve the issue, and to start the clock again.
Coming up to the beginning of the synchronized sequence.
So to be clear, they do have a launch window.
Attention pour la séquence finale lanceur. Top I0 moins 7 minutes.
And the synchronized sequence has begun. Raymond Boyce, the Range Operations Manager, or DDO in French, has announced it. And Ariane 5 standing tall for a sunset liftoff.
So we're just 7 minutes left to go here on the launch clock. Everything's been going according to plan so far. It looks like we're going to be in for a beautiful one because it's just approaching sunset at the French Guiana site. So we may get a bit of a spectacular light show. I don't think they're going to show the upper stage, so we might get less of a show, but maybe the ground cameras will be able to catch some cool views of the sunlight lighting up the engine exhaust. But that kind of depends on whether you can see it through the cloud layer, which is looking quite thick today. They do have a launch window that is, I think, like 2 hours long. So they do have ability to recycle in the case that they do end up having an issue on the way to launch. So just keep that in mind. Just because they call an abort or something in the last 6 minutes here, that's not the end of the story for today necessarily. Yeah.
Some of her highlights.
I think they're going to do a highlight reel now. Awesome. Yeah, that's the one problem with Ariane 5. It's not really a pointy nose cone, huh? But that wasn't, like, the whole purpose of the Ariane 5 is about payload delivery, not about the aerodynamics. I don't know if it's necessarily true that no matter which planet you're on, it's the same amount of fuel to get to the sun, because it's actually a lot less fuel the further you are away, which might sound counterintuitive, but you have to cancel out your velocity that you have in, like, the rotational direction, and the velocity you have in the rotational direction is much higher if you're closer to the sun. So because Pluto, for instance, orbits much slower around the sun, it's easier to cancel out your velocity out there and have your orbit fall into the sun than it is from, like, Earth. So kind of counterintuitive. Further away you are, less fuel it takes. Yeah. I kind of can't believe it's the last Ariane 5 launch. I mean, it's been there basically my entire life. But yeah, I guess it's on to bigger and better things. I feel kind of the same way I felt when they retired the space shuttle. That was also a big moment. But I think what's come after the space shuttle has been positive as well. So I hope that Ariane Space also has a positive path that it takes as a result of this transition to the Ariane 6. And their path towards moving towards cheaper vehicles is probably a good one, I would say. Although it would be really nice if they also incorporated some reusability, because that will make them cheaper in the end. Well, it's a little bit sad that you wouldn't have noticed. Yeah. I think Ariane Space does a much worse job of, like, advertising their vehicles and stuff to the general public. So I'm not surprised that you didn't notice.
Legend indeed, and what a beauty.
Gives me goosebumps.
It does. Goosebumps. It's very
Are you talking about that chair right there? Yes, it's a chair. It's being used to prop up the green screen. I have very high technology here in my studio / living room.
Now we're going to commentate from here now for the rest of the program.
We got about 2
minutes.
2 minutes.
And 16 seconds to launch. And I guess it would be a good time now to run through some of the things people should be looking out for.
Yeah, so only 6 seconds before liftoff, we will see the cryogenic arms retract. That's very last minute because the propellant it provides to the upper stage is extremely cold and constantly evaporating in this warm tropical climate. The Vulcan engine will ignite first. We will need to check it's working properly before we switch on the boosters. This will happen 7 seconds later, so we won't see the launcher moving during these 7 seconds. This is just a little warm-up before the very last Ariane 5 rocket takes off to the sky. Can you imagine, Katie, that next time the satellites will see the outer world, it will be in the emptiness of space?
So just as it goes here, don't get too freaked out. Basically, that main engine is going to start up, the one in the middle, like 5 seconds before it's actually going to let go. So just because it's not going anywhere in the first couple of seconds after it ignites, don't worry, it's supposed to do that. It's once those solid rockets get ignited at T-0, that's when we should see some action. So, all right, here we go. Just a minute left. I think we lost the clock. Wait, did we lose the clock? Yeah, we lost the clock. Oh man, what is it this time? Okay, I'm not exactly sure what happened. Oh, we're in found account. Here we go.
10, 9, 8, 7, 6, 5, 4,
There it goes.
3, 2, unité.
Engines on.
Top, allumage moteur Vulcain.
Ignited. Yeah, here we go. It's off.
Allumage 2 EAP, décollage.
The last flight of Ariane 5. Here it goes. Looking absolutely fantastic. That's the end of the era of the Ariane 5.
Tous les paramètres à bord sont normaux.
It's really a spectacular looking vehicle with those solid boosters, I have to say.
Pulsion nominale.
Yeah, they trolled us a bit there with getting rid of the clock. What the heck?
Syracuse-4B and Heinrich Hertz satellite blazing a trail on board the last ever Ariane 5 across the equatorial skies, and we can hear the rumble of her engines as she flies over.
It's very impressive, and we are, 11 kilometers from the pad, and the delay of the vibration is a bit amazing. We cannot get tired of it, and we have a very good view of the launcher right now.
I like what it looks like right now, where it's just like just reaching the higher altitudes, and you can see like the vapor trail of the cloud behind it. Really nice.
To the launch, fantastic view of Ariane 5.
Well, we have a very good view. I'm sure we will see the booster separation.
If we
nominal.
Okay, look out for the booster separation.
Working perfectly, nominally, as we say in the space
jargon.
And here we will see the booster separation. Yeah, we see it.
Right there.
That
was separation just there.
From the range operations
Look at
manager.
the boosters.
Look at this.
This is fantastic.
Amazing.
Those two boosters on the right and the left being jettisoned. The white dot in the middle, the Vulcan engine.
This is probably the
So they are
best
providing
separation we've seen with
percent of
Ariane
the
5.
overall thrust. And so they have been jettisoned. They are 240 tons each. The launcher on the ground was 771 tons.
And we don't need them anymore. We're shedding weight.
So everybody is completely nominal. So next step is the separation of the fairing.
That's coming up in about 10 seconds. You can see on the top of the screen our trajectory on the left-hand side is the planned route for the vehicle.
And the fairings have just
And
separated.
separation there of the fairing is what it looks like.
This looks good.
Séparation de la coiffe.
We have confirmation there of separation of the fairing. So we don't need it anymore, Raphael.
Propulsion nominale.
Exactly. So we were 117 kilometers above the ground when we separated the fairing. So we crossed the limits of the atmosphere. We are now in space, where the remaining gas is so thin that the friction it generates on the satellite is very negligible. Just to mention also that we switch.
So now, just to show you a little bit how this works, you can see the trajectory of the vehicle on the graph there with the yellow line, the vehicle on top. It's showing you the down range versus the altitude. And they're going to be going up to an altitude of, I think, a couple hundred kilometers, around 300 kilometers probably. And then on the right-hand side, you can see the different metrics. So you can see the specific altitude, you can see the distance downrange, and then, of course, the I think it's the delta V, which is telling you how many kilometers per second it's going. Once it gets to 7,800 kilometers a second, or sorry, 7.8 kilometers a second, then it'll officially be orbital. So that's the number that we're looking for. They're going to be going to geostationary transfer orbit, which is actually more like 9,000 kilometers. 9 kilometers per second. So that will be the final speed that they try to get to. Yeah, the clock did stop, or didn't stop, it was just disappeared for a little bit, which scared us a little bit before the launch, but in the end it was all fine and launch continued as normal, so nothing to worry about.
They saw the outside world. Well, now Heinrich Hertz can see space.
That's the case for the upper passengers. The lower passenger, Syracuse-4B, needs to wait a little longer in order to meet space for the first time. What we see is the black structure. This is the dual launch structure called SILDA. So it's used to accommodate the two satellites under a single fairing.
So everything's looking nominal right now. The trajectory is on course, so this is good to see. And we're about halfway to the insertion velocity, which is, again, around 7.8 kilometers per second. But it's going to keep going until it hits about 9 kilometers a second, because that's the geostationary transfer orbit energy that we need to hit in order to get out to delivery velocity for these two payloads. Another interesting thing about the Ariane 5 is that it actually cannot reignite its engines. So they're basically turn on and that's it. Which is no problem for the kind of missions it tends to fly. But basically it means that they can't do like those like stop and starts like they do with the Falcon 9 or some other vehicles. Also makes it a little more action during the launch period, because again they don't have those big pauses, so they have to basically pick the right moment to get the payload all the way out to its final orbit.
With the very hot boosters on the side when they are burning, and of course that's just such a remarkable feat of human engineering, isn't it?
Two extremes side by side. So everything is going perfectly right now.
We're flying out across the equator. Our flight path takes us across the Atlantic, across Africa. We'll be heading out towards the Indian Ocean. And he's telling us that we have now picked up the signal at the ground station in Natal, which is on the northeastern coast of Brazil, and we're tracking the launcher using telemetry.
Yeah, so the launcher sends signals back to Earth all along the flight, which are recorded by a network.
One thing that I'm really hoping for on the Ariane 6 is that they actually put some cameras onto the upper stage. I would love for them to actually transmit that. Because really, we have no idea what an Ariane 5 looks like after those boosters separate, because they have never put a camera and showed it in a live stream before. I don't even think Arianespace has released footage, just like not live, of those events, which is really a shame, because like we've never really seen an upper stage in action for Arianespace. We're missing that. Yeah, the engines that they use are actually, it's actually quite a cool engine. It's got this like really long combustion chamber because of it's using an expander cycle. So it's yeah, it would be awesome to see, to be honest. But yeah, okay. Maybe not a priority on Arianespace's books, but I mean, come on, guys. Got to share with the world a little bit. Okay, so we just had separation of the core stage, and now you see the ignition of the second stage. And we should see the velocity increasing again, which we are seeing, so that's good.
Allumage de l'état supérieur cryo.
So he's just announced and confirmed a sequence of 3 very important and very delicate events.
I think there are engineering cameras. I mean, there have to be engineering cameras. I mean, how else would they diagnose failures and stuff? But of course, these cameras are not usually set up for like live streaming and stuff. And they probably have them in sensitive areas that maybe they don't want to show the entire world. But still. Another interesting thing about the Ariane 5 vehicle is that because it has so little like power, should I say power, it has such a low delta V, sorry, not low delta V, they have such a low like force that the engine produces. In the last stages of the flight, they don't actually just fly parallel to the surface of the Earth. They kind of fly at a little bit of an angle. If you've ever played Kerbal Space Program, you'll know why you have to do this. It's what happens when your engine's a little bit underpowered. And it just means, it just keeps your apoasis ahead of you so that you basically don't come crashing back down into the Earth. And you can use a lower power engine and still manage that. So Taha is confirming there are engineering cameras on the Ariane upper stage, and he should know because he worked on it. He's actually, he is the propulsion, he was the propulsion lead in ASTRA, and he worked for about a year in Arianespace on the upper stage. So I would trust his judgment on that. Yeah, see you later, Xerxes. Great to have you, and yeah, take care. Now, I don't like it so much that they're making the live part of it go away here, but I guess we can still follow along on the right-hand side with where the mission is. As long as the velocity keeps increasing, I think we're still in a good place, so all should be good. If you look at the altitude graph in like where the little yellow line is, you'll notice that the altitude is now declining a little bit. And again, that's just because of the trajectory that they're going on, where because they have a underpowered engine a little bit, their altitude does fall a little bit during this phase of the flight. But don't worry, it's not going to crash into the ground. They are essentially angling the engine a little bit so that they can increase the apoasis in the next phases of the orbit here. The only negative of performing a maneuver like this is that technically you do actually lose a little bit of delta V. But they more than make up for it because the engine is running on liquid oxygen and liquid hydrogen, which is basically the most efficient type of engine you can possibly engineer. So if you look at the specific impulse of this engine versus like the Merlin engine, which is on the Falcon 9, this one runs at about 450 seconds of specific impulse, whereas the Falcon 9, the Merlin engine runs at something like 330. So it's quite a vast difference.
Tony is the Director of Space transportation systems at the European Space Agency. Tony, thank you for joining us from the fishbowl. Space Team Europe, it was very inspiring to see those people talking. What does it mean to you?
I saw a team with the Space Team Europe for the first time during the James Webb Space Telescope launch in December 21, and I find it a great idea. Space is booming right now. There's an acceleration of the use of space, and above all, an acceleration of the commercialization of space. Unfortunately, this is going much faster outside Europe, in the US and China, and also India is catching up very fast. The space economy is foreseen to be booming in the coming decades, and in order not to lose out on this, like we did in the dot-com economy 20 years ago, we must get our act together and accelerate the use of space in Europe. All the various players.
I love what this guy is saying.
Users to the space industries and the funding authorities will stand much stronger with a common vision and common goals.
Tony, thank you very much indeed. I appreciate you.
Sometimes I feel like there's a lot of sentiment in Europe about how we have to, quote unquote, get our act together in order to make sure that we don't miss out on the opportunities of the expanding space industry. But then when, push comes to shove, it's so difficult to get funding for things that are space related. So I feel like sometimes the words are there, but then, are the actions there? Not always. Yeah. I hope that Europe can get some more, there needs to be some more grassroots funding. So, if you want to build a space economy, you have to start from the bottom. If you don't have people that are excited to and able to contribute to the space industry and be engineers and solve problems that are space related, coming out of university, then it's really tough to start building up an economy that can handle that. If you look at the dot-com economy that built around in America in the 2000s, we had a whole bunch of students that were really interested in doing that, and lots of different startups that were popping up that were bringing these students in, and a lot of capital that was going into developing, websites and different types of technologies for things like your phone, the internet, and different types of technologies and stuff. We need that type of incentive behavior around space as well, and I think that's what's lacking. If you want to start up a new idea or a new project in Europe, it can be really hard to get funding, and I think that's a bit of a drawback, is that there's usually not a huge long-term vision behind these things, and there needs to be a little bit more money behind these words that come out from these governmental organizations about how they want to make space a priority. Anyways, that's just my 2 cents.
Extremely cold temperature in order to maintain the oxygen and the hydrogen as liquids.
So it looks like we're coming up now on probably about halfway through the second stage burn. You can see its progress there in the lower right hand side. The yellow line is showing the altitude of the vehicle as it travels across the surface of the Earth. But the key thing there is the velocity that you're seeing on the bottom number. On the right hand side, it's the bottom of the 3 numbers. That is currently at just under 8 kilometers a second. It needs to get up to about 9 kilometers a second in order to be at the velocity that it needs to get into the geostationary transfer orbit. And once it's there, then it's going to perform the separation of the payloads, and then basically the mission will be over. Yeah, what do I think about the idea of technology moving too far? Good question. Well, what kind of technology are we talking about? I think that's a good place to start. Because obviously, maybe I'm a little bit old-fashioned in thinking that, yeah, I would like us to remain human. So technologies that are going to make us transcendental humans or whatever, like putting chips in your brain and stuff, maybe that's a little bit freaky to people like me. I kind of like to live more in the real world than in the computer. But that's not the only technology, obviously. Like everything is a technology. I would like to see much more movement on technologies that allow us to live more vicariously, should I say. So things that can transport us faster, move us further, enhance our everyday experiences. I think I think that can't move fast enough. I mean, come on. I would love to be able to, have an everyday person go to space, walk on another planet, those types of things. I think that's something that adds to your real experiential world. I think is a good technology. Technologies that take us away from the real world, I think that might be a technology that potentially is moving too far. I think we should always be trying to connect with the world as opposed to distancing ourselves from it. Yeah. But that's just my opinion. I'm a rocket engineer. I'm going to have some I feel like people that like to build stuff and, see stuff fly and things like that are probably going to be more on that side. So we're still in the second stage burn here. It still seems to be going quite nominally. Nothing too crazy. It has a little bit left to go in the second stage burn here. I think it's probably about a minute or two. And then we should see the shutdown of the second stage engine. At that point, the only thing left to go will be the separation of the two payloads. They probably will not show that with the camera, of course, but we will at least see it on the screen happen for what that's worth.
The 3rd Foreign Infantry Regiment, one of the Armed Forces units in French Guiana, marks its 50th anniversary. 50 years of expertise and protection at the service of European space activities and international influence.
Travelling at 8 kilometres, just over 8 kilometres per second. Our distance, 6,000, nearly 7,000 kilometres from the pad, and an altitude of 270 kilometres high. We're really starting to climb now into space. And there are people all over Europe working in space transportation. They're represented by an organisation called the Community of Ariane Cities.
Yeah, I'm sure I'm sure that my children will have a different opinion than me about what technology is quote unquote normal and what is affecting our evolution or whatever. They'll grow up in a world that is, that has all kinds of what I would call transcendental type of technologies where you're altering reality, and that'll just be normal to them. So what I do actually worry about is that in the future, all of us that are alive today will, of course, not be alive. And no one will be there to really be someone who's holding the flag of normal. And normal will change into something that is different, and humanity will just, evolve into some technological state that is not really human. That's a bit of a fear I have. But there's not really much we can do about this, I don't think. Because ultimately, it's in the hands of our kids and their kids All we can do is be bitter about it when we're old.
The engines in previous Ariane launches.
Ariane Group et la ville ont un lien indéfectible depuis des dizaines et des dizaines d'années. Le site de Vernon est d'une grande importance, une importance stratégique pour l'accès à l'espace. 1946, 50 ingénieurs allemands spécialistes des missiles V2 arrivent à Vernon et contribuent à créer le LR.
So I think we're nearly done here with this second stage burn. I think it just finished, in fact. I think the engine just turned off. No, it didn't. It's still going. Never mind. A little bit more to go. You'll notice two things. If it does stop, either the velocity will no longer be rising, but also on the animation where they showed the rocket, which you see there on screen right now, the engine will actually probably go out, I think. Yeah, you see it's still burning there. They're kind of rotating the camera around the 3D animation. But there is a little blue flame on the back. That means that it is, in fact, still on.
Yes, in order to prepare the separations of our first satellite, H2Sat, so it's important to do it on time in a very precise way, as it will really drive the satellite's lifetime in space. Ariane 5 is famous for its injection precision. We've seen it for the launch of James Webb Space Telescope a year and a half ago, and again for JUICE spacecraft in April. Ariane 5 was so precise that it considerably increased the life expectancy of these space probes in space.
Indeed. Oh, the engine just went out. There we go.
Extinction de l'état supérieur cryotechnique.
So the video confirmed that it got successfully cut off.
And it was in the correct trajectory, so this is good.
Début de la manœuvre d'orientation au profit de Heinrich Hertz satellite.
So we'll be separating
the orientation maneuvers
OHB satellite
for
first.
Heinrich Hertz satellite.
So there's a special orientation that the satellite has to be in when it gets released. So the vehicle will now like do a little spin in order to get it in the right orientation. It's just to make sure that the solar sails are in the right position, or the solar shielding, depending on how it's shielding itself from the heat. These phases are kind of critical because if your satellite is facing the wrong way, it could have some problems with deployment, and then that could potentially cause some sort of a failure in the deployment series when you're just opening up your solar panels or opening up your thermal management system, things like that. You want to try to minimize the chance that things will go wrong. So there's usually an orientation that the satellite has to be in, at least for the big ones. For the CubeSats, no one cares. Yeah, that's an interesting idea, Benjamin, I have to say. The idea that we don't think as much anymore because things are just kind of done for us and there's less, chaos that we have to deal with on a daily basis. And yeah, if you want to start your own religion, that works too, I guess. Oh man, I hope we're not going to become robots. That's not cool. That's kind of like a dystopian vision you're kind of having. Yeah, we definitely need to exercise our brains a bit more, do some more thinking.
And the trajectory. Most of the data is not analyzed in real time. It's analyzed offline by dedicated teams in the days and weeks following the launch. So that's why we...
Rocket science is a great way to do a lot of thinking. I can confirm that. My brain's been in overdrive for the last year. Yeah, so many problems you have to deal with. Just like, it's truly unbelievable in some senses. Like, I'm probably solving like 2 or 3 problems every single day. It's, yeah, sometimes almost too much to take, but it's a lot of fun. You have to use your brain.
And in order for them to be able to do that, we have to set them off on their journey properly and to their exact position and orientation in space.
Absolutely. Actually, each satellite has its own set of requirements for being released into space in very specific conditions. For example, for an enriched Hertz satellite, we need to release the spacecraft such that it is slightly rotating on itself at a speed of 2 degrees per second. You know, like a barbecue spit.
This is actually interesting. So they actually want the satellite to spin after it gets released. And the reason for this is because you don't want one side to get too hot. So basically, if it's spinning at the start, then you're going to keep it from like, it's actually just like a barbecue, because the sun is the heat source, and then you're just, kind of rotating it so that the heat gets evenly put onto the spacecraft.
Of the satellite.
Ariane 5 has a fantastic track record.
Yeah, of course. Well, in 27 years of operation, 239 satellites into orbit, it constantly improved.
And only one failure.
Performance.
They had one failure.
Quiz with you.
Oh dear.
What was the fastest Ariane 5?
I don't know, but I have a feeling you're going to tell me.
That was for the Mercury mission Bepi-Colombo.
Oh, no way.
October 2018, the rocket reached almost 11 kilometers per second.
Wow.
Fantastic. 11 kilometers per second. That's a phenomenal speed. Coming up now on the first main event.
Oh, here we go.
Sat separation. That's
Just
what
separated.
It looks like up there.
That looks good.
Séparation Heinrich Hertz satellite confirmée.
And we have separation of Heinrich Hertz satellite. Our first satellite has starting its new life in space. It needs to climb to 36,000 kilometers. And obviously a whole load of things have to happen in the meantime. But we still have our second passenger inside the cylinder. Can't see it right now, can we?
Yeah, very good news, of course, but the mission is definitely not over. So the teams are extremely focused because we have another passenger to deliver into space.
So on the point of the fastest Ariane 5, the reason why Bepi-Colombo had to go so fast is because it was going to Mercury, of course. So it needs a lot of delta V in order to escape Earth's orbit. So usually Ariane 5 goes to the geostationary transfer orbit, but sometimes it goes further with payloads like Bepi-Colombo that are going to other planets. You need a lot of delta V to get to Mercury because, of course, you're going towards the sun, and towards the sun is always a lot more costly than going the other way. So that's why, yeah, it needed quite a lot just to get into the orbit that it went into.
In the direction of the sun, this time, with the thrusters directly pointed at our star.
Coming up now on the next part, the important phase of removing the cylinder so that we can reveal Syracuse-4B inside. That clever piece of kit, the attachment kit, which allows us to attach the satellite in the upper position and protect the satellite in the lower position.
It should happen in any seconds.
So that's the cover that's going to come off. This is what separates the two satellites while they're
moving very
traveling together.
And very, very slowly away.
Séparation Silda confirmée.
And we have confirmation there that the cylinder has now been removed.
Another very good news.
Now, of course, they have to be careful because they can't push the satellite out faster than that cylinder. Otherwise, the satellite could crash into the cylinder. I always wondered about the the potential danger of that. But I guess they do actually, I think they might actually rotate it a bit after, just so that that's not a possibility. Because I could see that being an issue.
also mention that the two satellites are separated with a safety distance in order to make sure that they will not collide with each other.
Oh, there you go.
They are following the same trajectory towards the geostationary orbit.
Should be impossible for them to collide.
In this case, it's dozens of kilometers that separate the two satellites, thanks to the orientation maneuvers that are being performed right now by the upper stage.
The teams at the Malindi tracking station keeping their watchful eye now on all these operations and sending back the data here to the CVI teams, who then provide that to the range operations manager, Raymond Boyce, to announce.
Looks like we have separation.
This is the scheduled time for separation.
Let's see the call out.
Séparation Syracuse-4B confirmée.
And we have separation of Syracuse-4B. That's great news. Ariane 5 has delivered her second passenger. Bang on target.
So that's it, guys. That's the final mission Ariane 5 had to go through, and it's been completed successfully. So absolutely fantastic. This is a great retirement to the vehicle. Really cool mission that they just performed. The camera footage was great, which is always a helpful little bonus. Yeah, I'm looking forward to the Ariane 6 vehicle, of course. But don't feel too bad. The Ariane 5 had a great history. It flew over 170 missions. It was one of the most reliable vehicles on the market. And I think it had some of those iconic missions associated with it. So I'll always look back fondly on the Ariane 5 as a vehicle that launched some of my favorite missions. And there are still lots of missions that are still operating that Ariane 5 launched. Like, for instance, the James Webb Space Telescope, Bepi Colombo, also the JUICE missions, and all of those will be giving data to us well into the 2030s. So yeah, definitely looking forward to what's up in the future for Ariane Space, and happy that the Ariane 5 is able to retire on such a positive note. As for ASTRA, we're also happy that we got through our propulsion testing, and yeah, for more updates on how that went, be sure to follow the channel. We're going to be posting, of course, some videos about the propulsion testing, and you're going to see all the juicy details of our hot firing and a little bit of a spoiler warning for the 5th propulsion test. We did have a small explosion, so of course we will be showing that on our channel as well. Yeah, should be exciting. Anyways, guys, thanks for joining. I hope you guys join next time. Remember always to keep expanding your horizons.